So, uh, is Hadoop a necessity for data science? So that's our topic for today. So, moving on, the agenda is going to be pretty straightforward. We have a very clear agenda today. So we will see what is big data, what is Hadoop. So this has been making several rounds in the last couple of years. A lot of people are, it is still remaining a buzzword, and a lot of people are, trying to gain uh, rather, they want to get more, footprints. Many companies are trying to gain more footprints onto this big data, Hadoop, and all that. And many people are very curious, right? That curiosity level has really gone up. Okay. So what is a data product we are going to see? What is data science, right? In general, what is data science, right? This is something we will discuss. And why Hadoop for data science? And what is the necessity for data science? And we'll also, I'll tell you a small problem towards the end, a simple problem, how we can see that in Hadoop, right? That is something I'm going to, if time permits, I'll try to show you that as well, right? So here is our agenda for today. And moving on, what is big data and Hadoop, right? Let's try to demystify these terms, right? So uh, I think if you, some of you may have noticed, right? People with, people who have, I think many of you must have at least looked through the internet, Google, and various social media sites and YouTube and all that. There are scores of videos available pertaining to big data and Hadoop, and there are lots and lots of things, related topics in internet and all that. So it's all available in different manifestations, I would say. But is there enough clarity still there? That's a question which requires to be answered, right? What is big data and what is Hadoop? So can you can some of you just take a quick guess and type it out in your question window? What do you think is big data, right? I just want to keep it a little more interactive here. What is big data, friends? Anything that is big, anything that is large, anything that is scalable. What's your, view about big data, and what is Hadoop? Just give me one answer, right? Just one word answer. Data within data, okay? Srikant says that. Anybody else? Just take a guess, okay? Awesome. A lot of people are, yeah. I'm just reading the ones, which are coming closer. Framework to analyze huge data. Volume, huge volume. Velocity, variety. Managing high volume, not samples. Entire thing, huge data, huge amount of data. Manipulation, large amount of data which can't be processed with regular database. Awesome. I think, I'm very happy to, get a lot of great answers from all of you. I think you guys are not starters for sure, right? I think a lot of you have unstructured data. Beautiful, right? Data in terms of zettabytes, and yeah, brilliant guys. Hadoop is a framework to handle large data. Yeah, thanks all. So friends, if someone asks you tomorrow what is big data, what is Hadoop, you should know the answer. So anything that can be, the data that is big, right? So if you can, something which is of high volume, coming from different varieties, and which is coming at an alarmingly high velocity, right? So that is going to be a big data. Not only that, many of you have pointed out, it is also unstructured data, right? Data today, it's predominantly unstructured. When I say predominantly, it's more than 80% of the data is unstructured data, right? Things are coming from social media, ever since the advent of social media, right? So data is coming from various quarters, and we cannot just ignore the data, right? So, in back in good old days, I can still remember, like 2005-6 types, right? When someone is like doing something in Orkut, I think that point, Facebook was probably not there. Orkut was, one of the sought after things. Someone was doing that, people will look at that person like an outcast. Maybe he's not he's not very aligned with the job, or he's just like a wastrel kind of image, right? So today, social media cannot be ignored, right? So we do sentiment analysis, right? So a lot of major decisions are based on sentiment analysis, what we do in Twitter, right? And we look at, a lot of product insights come out of this. A lot of things keep coming, right? So major product decisions are made based on the decisions, based on the insights what we derive out of these social media and various kind of channels. So we cannot just ignore this. So times have changed. That's what I'm trying to say. So huge data, unstructured data, everything is big data. And Hadoop is a framework to handle this big data. Yeah. So coming to this, look at this exponential growth of data. Fine. Social, enterprise data, right? It's just a culmination of everything, big data put together. So big data can be either structured data or completely unstructured, right? So unstructured is something, something like your text data, your audio, video, something that cannot be structured, right? All these are unstructured data. And these kind of unstructured data is becoming more and more, we are getting more and more of such types compared to structured data. So that's the story about big data today, right? So we cannot, and the traditional systems, whatever we have been having overall, those systems are just not able to scale up, right? That's one of the reasons why we are looking at, big data. A lot of people are, they just want to jump into this bandwagon because they don't have a choice now, right? So most of the enterprises are, earlier they were dipping the toe. Now the curiosity is, even more, it has gone up and they really want to get on with big data, right? Can someone tell me, like, okay, one is the social media, they cannot ignore and all that. Can someone tell me what could be the factors for companies, corporates, enterprises to show the sudden, shift? It's like a tectonic shift, I would say, right? Why is there a tectonic shift of the mindset of these corporates, companies to jump into the big data? We cannot say that big data was, just came like yesterday, right? It has been there for the last few years, right? Probably 4 or 5 years, right? So why is the sudden rush? Can someone tell me now? Like, can someone guess? Awesome. Great answers. Better business, handle all types of data, predict what that will be interested in buying. Excellent. Yeah. Unstructured, maintain. Okay. Cost effective, genome. Okay. I like this answer, right? Cost effective. Mining the data, right? So friends, data analytics. Nearly 90% unstructured data. Yeah, all these are, all of you are telling very, very valid points. One couple of things, which really makes it more interesting for the customers is, one is for us to process this kind of data, right? The amount of data. Can you all, if you, for us to buy even a RAM, a 640 KB, 640 MB RAM, those days I'm talking about, it was seriously expensive. I'm talking about 90s, mid 90s and all that. So those were the days, and today the mobile phone, what we are, just for 20 grand, right? You get a fantastic mobile phone with octa core, it's phenomenal speed, right? And it has really, I would say that most of the tablets what we hold today, they are faster than many of the laptops available, right? They are really faster, and most of the work gets done through tablets itself, right? So things have changed, times are changed. We are just moving ahead, and we are in a very fast-paced environment. Things have changed, and it's going to be constantly changing, right? So that is, let's not forget that. Right. So what is powerful today may not be powerful tomorrow. Right. So big data itself will be a moving target, right? It's going to be a moving target. And the other thing is the cost to process the data, right? These kind of the hardware cost has really plummeted, right? One is the cost of processing, right? The hardware, those things have really come down, right? So the companies, they don't have the apprehension to try out this because they cannot. Also, the most important point is they just cannot ignore this big data any longer, right? So most of you have pointed out that it is good for predicting the pattern, buyer's pattern, and whatever business they are on, right? So it's critical for organization to keep in pace with the fast changing world. Jayant has pointed out. Great point. Yeah. So yeah, these are all valid points, friends. Look at this 3 V's, and if you look at IBM, I think they have added one more V called veracity, which is the your quality of the data itself, right? So uh, volume, variety, and velocity is there. Look at this vitality, level of importance, how critical it is, how robust it is, fault tolerant, monitoring, transparency, forensics, fraud detection for visibility. The big data is like, it just, it's like a central theme for all these bubbles, validity, corresponding accurately to the real world, statistical modeling, everywhere, right? The data is growing, data is big, right? So big data, even though I can say that it is going to be a moving target, but it's going to stay for quite some time now, right? Because all this data science, even our our experiment with IoT, right? Everything has got to do a lot with the data, right? Just a minute. So Hadoop is a programming framework. We see this adorable yellow elephant. Large data sets in a distributed computing environment. So look at this. I really like this part. Hadoop was the first, still the best tool to handle big data. Friends, let's not forget one thing. Today, I think if you have seen Hadoop, then people are talking about Spark, people are talking about Storm, people are talking about Flink. There are several flavors. There are a lot of projects that are in you know some are still in the research stage, some have come out, and some are you know they will become a official project a little later. There are lots and lots of flavors of Apache, open source. Those things are coming out, but if someone learns Hadoop, Hadoop still remains the favorite. To handle large amount of data, because there are a lot of fancier options like in-memory computing. People say different things, but Hadoop is the fundamental thing, right? It still remains one of the widely used frameworks to handle big data. Brief history of Hadoop. Look at this. Uh, it was established. Yahoo creates team under E14 to work on Hadoop. It became a project, operate at scale. Hortonworks data platform. I think some of you must have experienced this. Hortonworks has, they have this sandbox and everything. That's also gaining popularity today. So Cloudera, yeah, yes, Shrikant, thanks. So Cloudera is there. In fact, a lot of people, offer Hadoop platform, right? Hadoop remains an open source because, uh, Hadoop remains popular. One is it is open source. Secondly, it is very, very successful. It's cost effective. It is scalable. It's horizontally scalable. It is flexible. Okay, provides scale on economy. You can just go on, you can go on adding this. Balakrishna is asking, is Hadoop a technology or a framework? It's a technology framework. I would say it's more a framework, Balakrishna, to handle big data, right? Because Hadoop has it's a framework which has got two vital ingredients called Hadoop file system and the map reduce for processing the data, right? So I'll come to that. I'll come to that. I'll come to that. It's So it also provides stability and all that stuff, right? Hadoop. So look at this. What is horizontal scalability? Sure. Yeah, Srikanth has asked this question. I'll answer this, then I'll answer Damodara's question. Any language processing tools, I'll come to that. Yeah. So let me answer what is horizontal scalability. So friends, um, what I try to say is like, let's say you have a machine, right? You have a machine which has got about 2 gigabytes of RAM, right? You process 100 gigabytes of data, right? So let's say it becomes very slow because of the disk IO switch, disk IO, it keeps switching the IO for the RAM to load the data, things like that, right? Over a period of time, it becomes very slow, crippled. What you realize, hey, it cannot process this kind of data, this volume of data. You try to juggle around, you upgrade the RAM, you try to make the RAM to, let's say, 64 gigabytes. It becomes faster, right? Tomorrow you bring on another file which is probably half a terabyte. What's going to happen? The same problem will come in, right? Because it's not able to, the RAM is not good enough to sustain or to handle a file which is of much larger size, right? It gets crippled. So what we do, we keep go on upgrading. How far you can upgrade? You tell me that, right? You will be restricted. I mean, you cannot go on upgrading this. So the other option is you handle, you probably have a system, which is probably of, let's say, 4 gigabytes of RAM, right? If this system is not able to handle a large file, you add another 5 systems, right? These are commodity hardwares, right? So they're not going to be super expensive. You just go on adding it, right? So the way it is going to be handled is, it is growing horizontally, right? Not vertically. You're not going to, go on bubbling up one's particular machine, right? You rather add more terminals, which are far more cheaper and which is going to perform distributed computing versus computing on a single machine, single powerful machine. This way, the workload is distributed, so it becomes far more efficient. Am I answering your question, Srikanth? Are you clear now? Okay. So, is it related any of language processing? Friends, Hadoop itself was written in Java, just for your information. So, but Hadoop doesn't mean that, Hadoop has got a lot of ecosystem tools. It doesn't mean that, you need to understand more of, Java or anything. MapReduce, of course, you need, if you have Java expertise, it's good. But, it doesn't, there are a lot of other languages like, Pig is there, Hive is there, right? So you can use these languages as well, right? Which are completely, which abstracts the complexity of MapReduce, Java, and all that, right? It makes it far more simpler so that you focus on the problems versus getting stuck on Java related issues and all that, right? So that's the intent here. So, do we still use MapReduce or Yarn? Okay, Brynmoy. Okay, I think it is up to us. Yarn is more like a platform, friend. So it's more a platform, and Hadoop 2 uses Yarn, right? It provides Yarn, and MapReduce runs on top of Yarn, right? So there are other frameworks that can also run on top of Yarn. That's how it is. So we can use MapReduce on top of Yarn. That is what I want to say. So look at this distributed file system, self-healing data store. Yeah, MapReduce. So what we have done very intelligently today with with Hadoop is these two are combined, right? One is the storage, another one is the processing, right? These two are coupled. Fine. If you just rewind your memory, how it was handled, in a traditional system, right? So we always take the data that is stored in the storage area to the processing front, right? So when we take it to the processing or compute layer, let's put it that way, right? Storage layer to compute layer. When you take it, what happens? When you take it itself, it can cripple the network if the data volume is pretty high, right? So what we want to do is we we have merged these two things together in Hadoop. So one of the fundamental shift I would say in Hadoop compared to the traditional system, why it is faster is the processing is taken to the data, right? Versus the data is taken to the processing in the good old days, right? The data is taken to the processing, like you are shifting the data where it needs to process and all that. Today, the processing program or whatever, that is taken to the place where the data resides. Look at the shift. So the data doesn't need to be moving along the network, right? So we have made this super effective by this way. Let's move on from here. Computation co-located with the data, right? So that's very, very critical here. Co-design, co-develop to work together. Process, another thing, process data in parallel, thousands of commodity hardware nodes. Failure handled by software, which is self-healing. So when we say parallel processing, friends, what we mean by this is, for us, because data is stored as chunks or blocks in Hadoop cluster. So what we have, let's say we have a file which is of size 200 megabytes. So if the default block size, what we set in a Hadoop cluster is 128 megabytes, how many blocks we will be storing in the cluster? 2 blocks, right? One is 128, another one is probably 72 megabytes, right? So when we process these files, right, how we want to process, it will be processed, like imagine a file which is running to terabytes. It will be processed as individual blocks in commodity servers, and multiple servers will be processing this blocks in parallel. So which is a parallel processing, which makes it very, very efficient and pretty fast compared to the traditional systems. However powerful they were, they still cannot handle a very large volume of data. Designed for one write and multiple reads, there are no random writes, right? Optimized for minimum seek on hard drives, right? When we say minimum seek, see, the other one thing is Hadoop has got very high latency, in the sense, see, it is not suitable for a OLTP kind of processing. Suppose you want to get into a bank and look for, okay, Mr. Rajashekaran has come in to verify his account. If they look at his passbook, they want to pull all the Rajashekaran's details. What they just go by the account number, account name, something like that, right? They will have a primary key and all that. They are quickly able to get the data. Hadoop is not designed for that. Hadoop is more analytical in nature. It has got very high latency, meaning you cannot go and zero in on a particular row of data quickly. That is not possible. Okay, RDBMS can do that for you very quickly because it is indexed, it has got primary key, foreign key and all that. Whereas Hadoop has been designed to read data which is a very high volume of data, right? If you want to read 20 terabytes, RDBMS will take a day or two and still may fail. Hadoop can do it in minutes for you, right? So it has been designed for such kind of purpose. Friends, are you all clear so far? Am I going in the right pace? All right. Thank you. Thanks for the confirmation. Yash, blocks. Okay, Shrikant is asking what are blocks. Nothing, Shrikant. See, let's say just give me a minute. I'll just show you. I like my. I, mean, I like to use like a quick whiteboard. Uh, okay, I'll take a notepad. See, what I try to say is, let's say a file which is called test.dat, right? 200 megabytes is the size of the file, and block size is 128 megabytes. This is a default. right? So I allow B1, block 1, P2, right? So this is 128 megabytes. This one is 72 megabytes. Fine. This is how it be stored. So these are blocks, basically blocks. So the test.dat has been fragmented into two different blocks. So B1 could be stored in server 1. I'm just taking, giving you a very simple example. Okay. P2 should be server 2. Okay. So someone, Balakrishna says default block size is 64 MB. Okay, sure, Balakrishna. See, friends, just want to tell you in Hadoop 1, the default block size is 64 MB. In Hadoop 2, the default block size is 128 MB. Fine. Of course, this block size, it is not a sacrosanct field. It is configurable. So in another way, I can say you can go to Hadoop 1 and make the default block size to 64 or to 128. And to Hadoop 2, you can go and set the default block size to 64. You can do anything. Or you can even make it 300 as your default block size. So this is a configurable parameter. But by default, Hadoop 1 is 64. Hadoop 2 is 128 megabytes. Yeah. So that is something you need to understand this. Thanks, Balakrishna. Thanks for raising that question. Blocks are Shrikant, blocks are data. They are basically data blocks stored in server. You got it? Stored in server 1, they are physical data, but it has been distributed that way. It's like a chunks of data, right? You're just pulling part of the data and keeping it in server 1, pulling part of the data, keeping it in server 2. So by pulling this, we are able to process. When we process, we do parallel processing. You got it? Divided into blocks. Exactly, Srikanth. They are divided into, yeah, thanks. So that is key power of Hadoop. Someone asked, one is the data locality, which is nothing but they are co-located with the data. Computation co-located, one thing. And again, processing data in parallel. These two are very, very vital. You need to understand this. Data product, software system whose core functionality depends on the application of statistical analysis and machine learning to data. So this is a data product. So that is also it is used for. So look at this. People you may know. I think what is this? Does it ring a bell to all of you? What is this basically? It's a LinkedIn, right? People you may know and all. So can someone tell me, friends, what could be the logic here? People you may know. What is this basically? Any guesses here? Associations, matching skills, all are correct. Brilliant. Manish is saying recommendation engine. Yeah, that's exactly the word I was looking for. Brilliant. So yeah, other answers are also correct. But this is the concept here. Recommendation engine. Friends, any idea? See, just want to give you a small picture about that. There are about 300,000 active members in LinkedIn, right? The figure could have gone up by now, okay? But now, see, the point is, if you need to go and connect with people, right? You need to go and connect with that many number of people. I think you'll probably drop LinkedIn and go to some other site, right? People will lose patience, right? It's just not going to work. What they have smartly done, I think some of you have pointed out, commonality. They look at commonality and pick up some of the common attributes, patterns, right? And they try to link you up. Whether you worked in the same company, okay, same profession, same designation, something like that, same technology. They try to do all this smart matching, right? Associations. They do all these things. Okay, then they prompt, and it so happens, I would say at least, 60, more than 60%, you will, it should be like a familiar face to you, right? Or familiar, I would say that, 60% you will go for it. You will go for it and, think that, this is working, right? Versus The other, this is something, it's more successful, and that is something you cannot ignore, right? So they've done their job. That's what I'm trying to say. Do you all agree with me, friends, on this part, the recommendation engine of LinkedIn? Okay, thank you. Spell correction. Yeah, again, see, do you want results for this, right? So they do this as well. What it relates to Hadoop? Shrikant, I'm coming there. I'm coming there. I'm coming to that part. What is data science? I think, yeah, Shrikant. So your question will be answered pretty shortly. So what is data science, right? So extracting deep meaning from data. Data mining, finding gems in data. Data mining is hard work, but there's a lot of gems hidden in there. How many people think that data means a lot, right? They also say, one of the trendy statement people make is, the recent, they also say the black, uh, the, a lot of people say that, the data, if it is analyzed, you will find gems. Okay, if it is properly analyzed. If you don't properly analyze the data, you'll find nothing. It's as good as like a dead data, dumb data, right? It means nothing. So the data analysis, right? That's a pretty vital thing. Okay. So let's talk about data analysis versus data science. Little bit. I just want to give you my perspective here. See, data analysis, it is, somebody from a strong business domain, right? Let's say that, you are given insurance data, right? Do you think a non-insurance person, somebody from a different domain, let's say, you are from financial domain, right? Will you be able to make sense of insurance domain data? Yes, no. Okay, some of it. Okay, no, no, no. In fact, okay, Sajid, I think I'll go with you. Some of it could be relevant. Yeah, you're right. But yeah, somebody from the, let's say, retail domain, yeah, with insurance, yeah, you will not be able to connect much, right? So because each domain, it's a mighty ocean by itself, right? And it has got their own domain experience, expertise and all that. So somebody from retailing, they will be very strong in that part. So they can do extensive analysis. They will know which algorithm to apply to get the best output or the best results and all that, right? Whereas if you give it to a financial person on some financial data to a financial analyst, he can do an excellent job, right? So it's very, very clear on that part. So that is more a, data analysis part. Data science, I just want to be, want you to have this difference very clear. Data science is more, it's more science than the analysis part, right? So an analyst will know which algorithm to apply for this business domain. Okay, whereas a data scientist will know how to optimize the algorithm itself, right? So it's more a scientific job, right? So it's, a data scientist will know, should we use this clustering algorithm or should we use some other algorithm, right? Random forest algorithm. Okay, should I take this linear regression or logistic regression, right? So a data scientist will not only know which kind of regression technique or which kind of logic which he has to do, he will also try to fix and optimize an algorithm, right? So he'll, that's more a, more a scientific job is what I want to convey here. Now look at this: descriptive and predictive, right? Clustering. So you all must have heard about it. Clustering is nothing but, grouping or classifying the data. Data classification is nothing but clustering. Outlier detection. So, Outlier is, again, you're taking a average of salary for a district, right? So uh, let's say it is $1,000 per person on an average, right? And suddenly, when you are analyzing the data, one person is shown 50 million, right? So it is an outlier, right? It's a data anomaly, or if you analyze it, it could be like a high profile sports person, or a movie star. It's possible to. So some analyst will be able to point out that. Affinity analysis, look at the occurrence of co-occurrence of patterns, so that is possible, right? These are all the descriptive aspects. Classifications, predict a category. Someone mentioned in the very beginning stage, they can do a prediction, why they are using big data, right? Predict a category. Regression, predicting a value. Yeah. Recommendation, predict the preference, right? All these are possible in this data science world. Now look at this: building data products, right? Delivering gems on a regular basis. Look at this: when the data goes through this processing tunnel, right? We are building a model and we are passing it to a data store, which is a persistent medium here, right? So we process the data and we send it to the data mart, let's say data mart, or like a warehouse, where we get a lot of BI reports processed and all that. Okay, it's just a depiction on that aspect. Why Hadoop for data science? Okay, sorry. Uh, Exploration, right, of data sets. So, friends, one thing I want you to understand before I go a little deeper on this is data science, data scientists, right? If you look at, even if you Google it and all that, most of them are like, they have a strong background in mathematics and statistics, and, they come from PhDs and, operational research. They come from such a background, right? So because they need to tune the algorithm, they need to optimize the algorithm. They work on things. They need to understand the how the algorithm works and all that. So they need to have such a background. Plus, you will be very, very surprised. Most of the data scientists spend, I would say, at least 60 to 70% of the time in data preparation. In other words, data preparation involves going by, cleaning up the data, because data comes in myriads of sources, right? It comes in different avatars. So they need to clean up, make sure that data is ready for analysis, right? Even for them to get to that stage takes them a while, takes them quite a while, right? Because data comes in unstructured packets. So they get, they spend significant amount of time doing that, right? So if you look at this data processing, exploration of data sets. So exploration is one of the, data exploration. Again, they they may do exploratory analysis. They can mine the data. Mining the data is like looking for insights and, looking for outliers. They look at the data dictionary and look for, as I told you, right? You cannot simply do an outlier, just like that. Some knowledgeable person will know why, uh, you know, uh, an anomaly versus a proper, meaningful data as well, right? Someone should be able to point that out. So all these are, you know, uh, the analysis part of it, right? It's quite a significant part before it is, properly, before we can make out any insights out of the data. First thing is we make the data, the structure of the data meaningful, so that it's ready for analysis. So that preparation stage is like very vital. Then we take it to analysis. There are a lot of steps involved here. Mining of larger data sets. As I told you, data mining, there are different models for data mining as well, different techniques used for, right? So people use, some of them use SAS, some of them use Hadoop, and some of them use R. So a lot of techniques are there. In we Our relevance here is like, why Hadoop, right? So we will look into the Hadoop aspect today. So what do we do? Better outcomes, right? When we do this, more data, better outcomes. So, friends, well, the other thing is like, the more and more data you unearth, you make analysis out of more data, right? Because even in your null hypothesis and all that, we always look at historical data, okay, and we try to discover patterns. So, one quick example, friends, something, the data science, how it has evolved today, right? So, most of the uh, let's say retail outlets, lot of these business domains have enormously got benefited. And I would just give you a small example. uh, Back in 2000, or at least 10-15 years back, right? uh, in supermarkets in US also, which was fairly well equipped and all that, right? So people used to give lot of coupons, lots and lots of coupons. Most of them will not make sense to you. Suppose I go to a supermarket, right? They'll give me coupons on home products, baby products. I'll just trash them without even taking a second look. Okay. Yeah, I'm coming. Upendra is asking how market researcher could use this Hadoop. I'm coming to that, Upendra. Yeah. So now, as times have evolved, right? Because most of them, you will just trash them, right? These coupons and all will not make sense. Now people have started observing the customers' buying patterns. They are making deriving insights out of it, right? They are deriving the buying patterns. Now they are sending coupons. They are sending, relevant coupons to relevant customers or buyers, right? So it really makes, and they, it not only gives, customer loyalty, it also gives, customer retention, customer, more customers, they go happy customers. It's a win-win for retailers as well, right? So it has become a very success. I mean, it's a huge success story for the uh, in the retailing. I'm just saying. I mean, I can replicate this story for so many other domains as well. Now, to answer Upendra's question, how market researchers could use this Hadoop? So can someone take a guess, friends? I told you a story, okay, which is a real story only. But how do you think Upendra's question can be answered? I think you already know the answer in a way. Where do you think Hadoop will fit in here? Any guesses here, friends? Look patterns, okay, identifying patterns, okay, uh, okay. Yeah, Ashish has got a point. It says Hadoop can store patterns of each customers, okay, behavioral, buying, other patterns, okay. So one thing, friends, parallel process. Okay, great. See, Hadoop can store this data. Okay, we are talking about a very, very large database, right? Because if you look at some of the major supermarkets in US like Kohl's, right? These Sears, these guys have moved on from their traditional Oracle to Hadoop. If you go to Sears, if you see their data architecture, they have moved on to Hadoop cluster properly, right? So data stored together, associated. Yes, Sajid. Yeah, maybe. Yeah, correct. So data intelligence, data, because we have got a lot of analysis tools in Hadoop, which can be used to derive, to analyze the data, right? We are, see, data science is all about, preparing the data and analyzing the data. So Hadoop can be very well used for data analysis and storing the data, and of course data analysis, right? So we need to store the data over and above. I mean, on that data, we analyze the data, right? We analyze the data that is stored. So Hadoop can play a significant role, major role in keeping the data, like storing the data, which comes at a very low cost, right? Plus, we also do extensive analysis using the data. Is that clear, friends? What are the analyzing tools? Yeah, funny. Analyzing tools, we have Hive, we have Pig, right? This Hive can help us analyze, and there is Impala. I'm not going to go there, but I'm telling there are lots and lots of tools there, and daily there are different versions coming up, but the major ones are Hive and Pig, I would say. Tableau is it's more a visualization platform. Tanish, funny, yeah, yeah. So that is more a visualization. It's a brilliant platform, and in fact, Tableau can work with Hadoop. Just to let you know, Tableau can work with Hadoop also. You can integrate it for reporting purpose. Absolutely correct. Large scale data preparation. Look at this, friends. 80% of the data says, okay, I was bit off. I said 70%, right? So 80%, significant. Look at this. Joins, entity resolution, strip away HT. You need to prepare the data that needs to be mined or analyzed, right? So the raw data, whatever comes in, will be completely unstructured. You need to really make the data, you need to prepare the data so that you make it more meaningful for analysis, right? You cannot simply analyze the data. Just imagine, friends, if the raw data comes in, which is your high fidelity data, absolutely, but same time it needs to be, if you want to analyze it, you need to bring some sanctity to the data, right? So you need to take care of these aspects. Okay, a lot of aspects, right? Sometimes the data will come in, I'll give you a very small example. Data comes in, like one source, it is coming, the date is coming as DDMMYY. Another source that is coming from US, it is coming as MMDDYY, right? So you need to sort out these things using you need to use uh, either a map reduce tool or something like some processing engine, right? You can even use Pig. It's an ETL tool to do transformation, to make it more consistent, right? You can use a regular expression. You can do all those things to do cleaning up the data so that it becomes consistent. Then once the data is far more structured, you can do the analysis. Yeah. So this is how the cycle is. Accelerate data-driven innovation. So today, one other thing, friends, there are not, the Apple, what we have, I may be talking something completely out of the whack, but I still want to tell you this. See, uh, most of the companies, if you look at the marketing strategy, right, they all come back and say that, they do a survey, proper survey, they do this pestle analysis. There are a lot of marketing, strategies, how you study the market, how you look at the segmentation, customer segmentation, and they look at the locality, they look at the location, and they look at the people. They do various things, right, before they launch a product. Not many of them are, Apple is like a 1 in a billion, right? Steve Jobs had the foresight. He said, I'm not going to go by the market, I will define the market, right? How many people have that guts, and how many people have that conviction to still succeed, right? iPhone succeeded, we all know that, but most of them, or if someone says something out of thin air, of course, Steve Jobs had the financial muscle as well to launch a product like this, spectacular product like this. But how many people will have that leverage, right? Think about it. So if someone gives a statement like that, you will say, hey, can you show me some backing source? Can you prove it with your data, right? Data plays a very vital role. So we always want to ensure that it is supported by some data facts, something which is data driven, right? So data driven innovation is far more, I would say that trustworthy, or it's going to be more believable, or it can, the chances of succeeding using data driven innovation is going to be, it's going to be higher than something which is not backed by data, right? So sorry, I went to that example, just to quote you that people, something which need not be data driven also can succeed, right? I wanted to tell you that. Look at this. Schema and write, change is expensive. RDBMS, right? High barrier for More data driven. Okay. Upendra is asking more data. Okay, anything, Upendra, I'll tell you. Let's say your World Cup soccer 2014. I don't know how many people watch soccer, right? The World Cup soccer, SAP Analytics from Germany, right? They did extensive uh, analysis on the data. They looked at players' profiles. They looked at how Germany was really. I would say that uh, I think I don't exactly remember the number, but I can tell you the overall strategy what they did. They figured out that the ball possession, right? The ball possession of every player in Germany, right? It was about six to 7 seconds, or or rather 5 seconds, I would say. They brought it down to by 1.5 seconds. So it became like 3.5, right? For every player who will be possessing the ball within themselves. So they were passing faster than how they were passing earlier. This completely disrupted the opponent players who were just not prepared. SAP Analytics gave this, they did this analysis and told the German team, if you do this, you can easily penetrate into the opponent's defense, and the rest is history. Germany went on to win the World Cup, right? And you all know how they ate Brazil for their lunch, right? In the semifinals, it was like 7-1 or 6-1. I don't know what was the score line. They just thrashed them. And Brazil, surprisingly, Brazil team had 51% of ball possession in the first half. Okay, Germany had just 49% the first half, but they were passing, and they completely demolished the defense of Brazil. See, I'm saying data driven, right, Upendra? There are so many things you can say. How people do the patterns, the buying patterns, whatever I told you in Sears, supermarkets, they are all data driven. Just for your information, everything is data driven. Is that clear, Upendra? Yeah, sure. So new data, finally we start collecting. Is it any good? Schema. See, look at this, right? Schema and right, RDBMS, we all know it uses, see, it is a very, very strict schema, right? The schema is defined well in advance. Then we start inserting the data. Fine. Then finally we start collecting more and more data. Is it any good? It's like high barrier for data driven innovation is like, if you want to change the schema after some time, it's going to be a problem, right? Because it's all fixed, right? Whereas it's a high barrier for innovation. Whereas if you look at Hadoop, right, you can just put anything there. You can just push an elephant onto Hadoop, right? Schema and read, low barrier. Okay, so it's simply going to put it in HDFS. You can write any kind of data, any kind of unstructured data also. It's a schema and read. There's a schema and write for RDBMS, right? So that way, Hadoop provides distinct advantage of the data being stored in a unstructured format and all that, right? It is schema and read. So this makes it a lot more flexible and fluid for data driven innovation. So Hadoop provides that operational advantage, I would say, in the long term, right? So friends, any questions before I show you a quick piece? Any questions so far? Schema and read. Okay. So friends, what we say schema and read is, see, when we are can you insert data without defining the schema in an RDBMS? Can you just insert the data? Yes, no. Into RDBMS without defining the schema? No. The answer is very clear. All of you know this, right? In HDFS, I don't need to define anything. I can blindly insert data, right? I'll simply go and insert the data that is possible in Hadoop, right? HDFS, which is your Hadoop distributed file system. Whereas in RDBMS, it is schema and write. That's why you can trust the data that is coming from RDBMS, meaning you are imposing the schema which is going to act as the gatekeeper, right? So it is going to have all the integrity, data integrity, everything is there. It's going to have this ACID property and all that. When it comes to Hadoop, schema is nothing but your design, Danish. Nothing but your design. Let's say in a table, Danish, quick thing is, in a table, you have rows and columns, right? Column one, I'm going to say name, age, gender, okay? Name is Danish, age is, let's say 20, gender is male, right? So this is your schema. Fine. So I need to have this very strictly defined in a RDBMS, right? So this is schema on write. In HDFS or Hadoop, I blindly insert the data. That's all. But while reading, fine, while reading, I can define the schema at that point, right? Suppose I want to load data through Pig. Pig is one of the ecosystem tools of Hadoop. When I want to load the data through Pig, I'm going to load it, right? At that point, I need to define the schema. That is schema on read. Okay, I have another question. My previous question, does Hadoop has any relation to natural language processing tools? Individual need that. Actually, see, NLP, it's more to do with text mining, Damodara. So, I'm not an expert in NLP, but I can tell you that you can still use Hadoop as a medium to process the NLP. You can still do that. That's possible. And it is not like you need to have the NLP to. I mean, it's if you're really doing the natural language processing, yes, you need to have the skill set. But if you're not doing that, you don't need that skill set. Pretty simple. Like people who do text mining, they need that skill set. Otherwise, it's not needed, right? Digital marketing. How much Hadoop system? That's a great question. Uh, Digital marketing. Sorry, Upendra, I'm not quite sure, but I'll try to find out. If because fantastic question, yeah. Because digital marketing, I know that it's the one of the in things today, but I don't know. I don't know where I can place Hadoop there. Maybe can Hadoop process the data from SAP? Yes, Max, it's possible. Because Hadoop has, I'm just guessing, Upendra. Max, I'm guessing. The point is, there are Hadoop connectors for most of the leading databases. So I'm pretty sure SAP will have a connector too. So Upendra is demystifying digital marketing is nothing but online marketing. Yeah, it's definitely yes, Upendra. So so your question on the digital, if it is online marketing, I can say Hadoop's. How can we use? Yeah, then I can say that online marketing. Let's say customer retention. Uh, you know, looking at the customer segmentation. You can customer profiling. You can use various things in these are all marketing exercises, right? So you can very well use it there. Security of utmost. No, Hadoop is fairly secure. It's quite secure, Mrinmoy. How can we use Hadoop in cards and payment domain? Uh, it is very well used in with I would say in PayPal. I would say and Visa. All these guys are actually using it, and they use Hadoop clusters in their organizations. And of course, it is secure too. How does it help? Yeah, I mean, see, people are going to Hadoop primarily because it's not for anything else. It is very, very cost effective, right? Because most of these guys are burning dollars and dollars in the costly hardware infrastructure, right? This has become completely highly cost effective, right? And it is, and of course, it gives a very good performance too. There are many flavors. Basic Hadoop Ashish has got a very long question. If so, what flavor, what according to you better to, an open source as a flavor managed by different vendors? Okay. Uh, See, Ashish, I would say plain vanilla Hadoop is great, right? You just need to know how to install that, and installing is not a big rocket science. You can easily get it done, right? I can clearly say that. So, and there are, these guys, most of the some of the corporates they prefer uh, Microsoft has got its HT Insights, and IBM Insights is there, and Cloudera has got its own. Hortonworks is coming and pushing their own. All these guys are coming up with the flavors of Hadoop, just like Linux distros, right? People have their own flavors, right? So I would say, if you're so comfortable using the plain vanilla Hadoop, that's great. Otherwise, you can always go for Cloudera and all these providers. They come and offer you this. So, but I'm very comfortable. I've been using the plain one, so which is very comfortable. Good on write compared to RDBMS? Absolutely yes, Neeraj. Absolutely yes. How can we use it in Linux? Yeah, you can just use it, Danish. Hadoop is available for Windows as well. Quite recently, they have launched that. It is by default it's suitable for Linux. Uh, Upendra is asking, Hadoop can process any kind of data. How can server protect password and ID? No, it goes through a secured shell, Upendra. There's no problem about this. Yeah, it's not an issue. It goes through SSH. Okay. So, friends, definitely I need the feedback. But before that, I just thought I'll show you a very quick, you know, a quick processing. If you can hold for another 10 minutes, right? 5-10 minutes, I'll quickly show you what is that fine with all of you? Yeah, excellent. So just bear with me. Sure. So I'll close this. Of course, towards the end, friends, after I'm done with the small lab, I request your feedback. Right. So that's very very important. Uh, as clearly stated here, be it a compliment or suggestion or complaint, be very upfront and provide your thoughts, because that's definitely going to we believe in continuous improvement, right? So please help me on that part. Sure. Thanks. Thank you, Upendra. Yeah. So I will go to the lab session. So what I want to show, friends, see here. Just give me a minute. I want to show something like if I have this. See, I open the terminal. Just give me a minute. Okay. I'll try to answer this question. Can Hadoop be helpful for Java developer? Absolutely, Devi. There's no doubt about that. Someone is Java, right? It's going to be supremely helpful. No doubt about that. So I want to show you something, very, very interesting here. Just give me a minute. Okay, I got it. So, okay. So friends, okay, I have a question here. What about non-Java? Absolutely funny. There is no, as I told you, right? Java, non-Java, it doesn't matter at all. A lot of people have reservation. Can non-Java guys pick up Hadoop? My answer is overwhelming yes. So not to worry about that, because big hive. There are so many flavors. In fact, I understand Java, and as much as possible, I try to use the non-Java part of it. The reason is it makes it even more quicker, right? You don't need to learn Java for that. So that's pretty much it. And what are the different type of job roles in Hadoop? Anil Kumar. Yeah, Anil, I think you can write from the being a developer, and analyst, and you can be a architect, you can be a data architect, you can be a big data architect, and you can be a big data programmer, and a lot of multiple roles. It depends, Anil Kumar, where you exactly want to go. Which NoSQL best to learn? That's like us. Okay, Neeraj, great question. There are about 150 NoSQL databases, right? There are 150 NoSQL databases approximately. So there's nothing like best to learn or anything. I would suggest take one NoSQL, right? You can probably start off with HBase or one of these things, right? Understand the nuances of NoSQL. Why? How is it relevant? How is it different from a traditional RDBMS? Then understand one NoSQL database. Then that will give you a vague idea about what is going on. Then then you can move with that. Yeah. So the others should be like there are different flavors available. Mongo will be better scope. Yeah, possibly yes. Mongo. Yeah. So friends, I want to show you something very quickly here. I won't take much time. Yeah, there are categorization. Indira is asking, yeah, there are graphical databases, there are columnar databases, there are, uh, what to say, a database which provides high consistency versus high availability, right? Uh, so different kinds of databases are there. You're absolutely right. Categorizations are there. So it's not like one you learn, the others will be, but you at least conceptually, I would say that there will be. You can uh, at least you can get to some point, but uh, there are like uh, you know like Google table is there, and hyper table, and some of them are derivatives of these families of databases. There are different families, but at least NoSQL, from that aspect, I'm saying if you learn one or two, right, it should give you a broad perspective of what a NoSQL database is. That's my point. How do we get data video formats in real time? Yeah, sure. Key value. That's right, Indra. Yeah, key value pairs and all that. What's the best? If I'm looking for key value, uh, key value, I think Redis is there, Indra. Yeah, Redis is there, and Cassandra is there. Yeah, these are all based out of key value pairs, I would say. How do we get slides and video recording? Sure. Slides of which one, Rajat? This session is recorded, Rajat. You may need to check with Edureka support. You just need to find out. The other ones, you may need to find out, whether this becomes available. I think you can check with the support. I'm sure they will help you. Yeah. So friends, just want to tell you, this is like a quick problem, right? I'm not going to go explain the overall things, right? But this is a simple analytical task. How Hadoop is playing a major role. I want to just tell you this, right? Look at this number of flowers, right? Can you all tell me your observations? Just a high level observation. They all look alike in a way. Is that correct? Names are different. Okay, there are a lot of just majority look alike. Correct. Yeah, friends. I want to just want to lead you on to this problem. These are all types of flowers, right? And this one, this is nothing but the duplicate of this. Okay, this flower is getting duplicated 9 times, right? So in other words, I have how many flowers here? 19 items selected, right? So I have how many duplicates here? One is here, and 9 times of this, so 10. So in other words, if I The problem statement for this exercise is to get rid of the duplicates. It's a pretty scientific problem. So let's say, we are talking about, I need to get 9 images, right? Let's say you are given 100 million images, fine. And someone tells you that, you are working for a cryptography project, which has got like fingerprint scanning and all that stuff, right? It's a very high sensitive project. They want the data to be treated with utmost confidence. Now they are looking at, various fingerprints they've given you. Now they are telling you to get rid of some of the fingerprints that have come as duplicates. Okay. And they say the number of duplicates could be maybe 100 or 200. How do you do this? Any vague idea you guys have? Any vague idea? Anybody has this idea, friends? Image processing tool, okay? Matching pictures. Upendra says that. Any other guesses, friends? Okay. So, well, what I am trying to say is it's a very scientific problem. How Hadoop uses, I just want to showcase that part. Beautiful, Anil Kumar. He says MD5 value, message digest value, right? So that's size of the file may not, Sajit. The point is, size of the file is a very misleading attribute, right? It could still, the size may be the same, but the file type, so many things can be, different, right? So MD5 is one of the, algorithm, right? So that gives you like a hashing value. Using that, you can be able to find the duplicates, right? So that is something, I just thought I'll showcase that quickly. I'll not be, taking much time here. So what I want to show is MapReduce input. I have already put these files, these images into this folder, right? Now I want to get rid of this. I don't want to physically remove these files. I would rather, instead of getting 19 entries here, my output should have only 9 entries, right? Ignoring those 10 duplicates, right? Overall. So this is it has the URI as well, where the flowers are stored. So what I want to convey here is like, I have my Eclipse. Just give me a minute. If I can show this quickly, it'll be great. Okay. Just a minute. Okay, I got something here. So friends, differentiate the duplicates. Okay, Rajat, I'm coming there. Differentiate. So what I want to convey here, friends, differentiating the duplicates is, the MD5 algorithm, right? What it does is, see, I'm going to first, if there are 100 million images, right? I'm going to put that in a compressed format, right? First, I'm going to put that as a sequence file, which is nothing but a binary file. Then Hadoop will not, I'm using Hadoop framework to do this, right? Using a MapReduce program, which is nothing but, it's part of the Hadoop. So I'm using MapReduce framework here. So what I want to do here is, see, I have this first thing. I want to keep all these files, read the files completely. There are 2 steps process to this, friends. Okay, 2 steps process. Just give me a minute. I'll explain you this. Then you can ask this question. Fine. There are 2 steps process. 2-step process. One is I want to convert everything into binary. So I'm not going to go too much deeper into the source code, but what I want to convey at a high level is I want to read the file one by one based on the URI, right? I already showed you the input, right? Then it's going to create a byte stream out of that. Fine, you got it. So that is the first step I want to do. Then the second step, okay, that is the first step. Second step is, this is my reading that file, right? I want to process image by image. I want to create a MD5, here I want to calculate the MD5, message digest file. Fine. So that is going to generate a hash value which I want to convert it into a hexadecimal. Fine. So if the hexadecimal matches, okay, I want to just drop that. So those are all duplicates. So again, there is something called map reduce in Hadoop, right? Map reduce is nothing but, map is processing, reduce is nothing but aggregating the results of the processing. Okay, so if I have 20 documents coming in, right, with each one of them, having different results, when I want to combine it and aggregate, right, that is what is your reduce process. Fine. So now when I do this reduce, right, first, I want to get in and, just do this. I process only the first time, because if I have 20 different identical values, I want to get in the first time and do a break so that, I don't get to process the duplicate ones. So I'm using the Hadoop framework very effectively, the Hadoop MapReduce framework. Any questions, friends, in this? How to run the same program without Java like Pig? Sure. I mean, we need to write logic for this, funny. It's going to be a lot more, simpler in Pig. It's going to be, fewer lines, and because it internally uses MapReduce, Pig internally uses MapReduce. So Pig is more like it'll do the, you don't worry about how it is done internally and all that. You just tell what needs to be done and Pig will take care of that, right? So that is something, Pig is extremely useful for. But, if there are completely unstructured and, audio, video files and all that, I would suggest to use MapReduce at least at the first level, because there are more supported libraries and, tools, sophisticated tools in Java compared to other areas, right? So you can exploit that. Then you go into Pig and for the second level of analysis, you can do that. No, it will not be time. Indra is asking Pig is something like SQL, PL. No, Indra, Pig is more like it's closer to SQL, I would say. Closer to SQL. If the memory in which duplicate is present is very large, no, it will not be time consuming, Rajat. It will not at all be. Why we want to do this into binary format is we want to process the binary. See, I told you about, the step. Initially, you can process things in chunks, right? If 100 million map process, runs, because these are all distinct images, right? Do you want to run 100 million processes in different computers? Is that very efficient? Yes or no? Because these images are very tiny, right? GIF files, JPEG, few are bitmap. They are all tiny files, right? Is it good to process that many files in, as separate process threads? Is it good to process 100 million files? No, right? We all know this. It's a no, because it's going to be overheads in collating them and all that, right? So you want to create because it's a very small file, right? You may want to process it as sequence files, which is nothing but, I want to compress them and, keep them tidy so that my processing, in fact, processing speed improves overall, right? You got it? So first thing, do you all understand the overall structure of the program, what I mentioned, folks? First thing, I want to convert that into a binary sequence file. Second thing, I want to read the file, get the MD5 value of each file, then go to this, the aggregation part, and because I'm not physically removing the file, I'm only putting the path. First time I do this for the same thing, for the rest of them, I jump out of the loop by doing a break. Are you all getting this logic overall? Do you understand whatever I'm saying so far? Okay, why we do, binary, why we do this is to simplify the, uh, you need to process it, right? You can't do, I don't want to treat them as, separate files and process, because that's going to be very, very time consuming. So I want to compress them. So that's why I'm converting them into binary. Fine. Secondly, when you want to process these images, right, I need to have it in some format. So binary format is the, compressed and shortest format I can have. Mohammed, are you clear with this? That's why we are doing this. Then only we can build some hash out of the file. First thing is we need to read the file itself, right? Then convert that into binary and all that. Yeah? Is that clear? Yeah. Okay. Friends, but overall, I want to ask you, are you understanding what we are trying to do with the overall files, right? The overall structure. You're understanding what we are trying to do. Is that correct? Okay, brilliant. Thanks, friends. So what I will do, I'll execute this. I'm going to convert this into a jar. Very simple jar. Give me a minute. Okay, I've done something. Let me go and check it out. Just give me a minute. Have the jar file right there. So I'm going to Hadoop jar. Okay. September 9 jar. And first thing I want to and give me a minute. My input is MR sequence. I think the input file MR input sequence sec input text. And I want to write the output to September 9th. Yeah. Just give me a minute. September 9th. Okay, there is a file. Okay. Yeah, I think I gave this MR. Oh, MR input. Oh, there is a folder in between. Okay, just give me a minute. Thanks, Damodara. Thanks for suggesting that. Yeah. So Mrinmoy is asking, distributing file in multiple slaves, then how do we compare each image's duplicate of? No, actually, Mrinmoy, the point is, see, it's going to be, it's going to be distributed. I agree with you, but when the binary file, whatever we are distributing, right? If it is stored in as distributed, right? The point is, we are going to keep this, right? We are the file. Okay, let me show you instead of talking about this, right? Let me show you this part. This part, right? This is my output. This file, this is my binary file. Okay. If this file can be distributed across the cluster, that's possible. this file itself, part 00, right? Which is our cluster. Okay, this file can be distributed if the threshold size of this file, if the file is above, let's say 300 megabytes, it can be distributed across the cluster. So overall, the framework, Hadoop framework, will take care when it processes. It goes and it can still process it as individual blocks. That's possible. So I'll tell you how it can be, because when we are doing this, right? See, my second part of the processing, right? This is my first part, right? I have converted that into binary. This is my second part. Okay, what will be the input for my second part? The output of the previous thing, which is nothing but this, right? Now I'm going to, let's say I want to do output September 9th, say final. Let me say that. Fine. So let's try this. So Mrinmoy, my point is, if that file, the output file, which is what you saw here, if that file is large enough, right, it will get distributed across the cluster. Okay, and the Hadoop framework by default, it's going to follow the thumb rule of data locality, right, which is nothing but it is going to take the program, which is this jar file and all these things, configuration files, these are all the programs. It is going to take them into the respective slave machines where it is going to run the processing. So now it has done this, right? Okay, now if I want to go back to the output, September 9th, you see a final. Look at this. The duplicates have been removed. These are all the hexadecimal, those values. You can ignore that, but my point is, you're getting only one flower, right? One auto load. These were the ones which got duplicated, right? Its hash value will represent aggregate, right? Yes, Indra. Yeah. See, the hash value or the MD5 algorithm, fine. So those images, when you are comparing two images, you cannot go by the size, you cannot go by the types and all that. But the hash value, the binary format, right? Once you create the hash value using the binary, it cannot be different. I mean, it will be the same for two identical images. That's my point. So we are gotten rid of the duplicates. Is that clear, friends, overall? See, Hadoop can play a very major role in exercises like this. You can probably, you can also how to avoid noise in a bar conversation. That's a very famous program too, right? We can use machine learning algorithm for that, right? So again, Hadoop can play a major role there. Is that clear to all of you? Okay. So friends, we have come to the end of the session, and hope you found it useful. If the images in the crop of the images, I don't understand this question, Rajat. Images is the crop. I'll try to answer Rajat's question, then I'll wind it up. So friends, again, as I requested, hope you enjoyed this webinar overall. So hope you found it useful. So I really want you to, provide the feedback as, as I requested earlier. Yeah, sure, Sajid. So Rajat, maybe if you can. Sure, Indra. Maybe Edureka can, help you to, solve provide this information. New images, crop of previous images, will it be? Yeah. See, any image, identical image, Rajat, it's going to have the same value. That's my point. Yeah. New image or old image, right? So it's going to be uh, you can find out this value and it will be the same. That's very much there. Yeah. So thanks, folks. Uh, Funny, I think I would suggest you can check with Edureka support. They're ruthlessly proficient. So I don't mind giving my number, but my point is like you would be better off because if I don't, I may not attend to your urgency sometimes, right? I may not see your urgency. You may get delayed. So please talk to the support team. I would suggest they will be very happy to help you on any doubts you guys have. Yeah. So I give the mail ID, folks, but my recommendation, please, I'll give my mail ID. My recommendation, please talk to the support. They are more than happy to help you there. Yeah. So I'm sending to all of you. So thank you so much. Hope you found it useful. Please, please, please provide your thoughts, feedback on this. So I'll be very appreciative if you can do that. Thank you so much, friends.